Hello, students. In this lecture, we'll talk about statement structure. There are different type of statement structures. We'll talk about those things, and we'll see different examples how we can write different, statement structures, different type of statement in our programs. So we understand what is statement. Statement is an instructions. So when we write a statement, that means when we write a statement, it performs some operations. Say, for instance, we write a plus x equal to a plus b. What does it mean? This is an assignment statement. We are adding a and b and get the results, and that result is assigned to x. So that's a statement. So these statements basically perform different operations. A statement might have several expressions. So we'll see those sort of things. So far we have seen that a program might have set of statements. So you have several statements, statement 1, statement 2, and statement 3. And we understand each statement perform some operations. So if you write a program, it has 3 statements. What does it mean? It means that your program performs statement 1 first, then go to the second statement, it performs the second statement, then it go to the third statement, then it performs the third statement. So set of statement that executes in the order they appear. So if you write in that way, your computer perform in the order that you write in the programs. You have statement 1, statement 2, statement 3. So your computer perform statement 1 first, then say statement 2, then statement 3. And this statement structure is called sequence structures. So you have sequence of statement and it perform sequentially, and that's called sequence structures. Say if I give one example, say for instance, this is your program, you have var assigned by 5, then your second statement has var assigned by var plus 3, and your third statement is print var. So these are the 3 statements. So your computer first perform var assignment by 5. So 5 will be assigned to var. Then your computer go to the second statement, then it will add 3 to var and get the results, and that result will be assigned to var again. So that means your var has 5 and you add 3 and var become 8 because you are assigning 8 to the var. And third statement, print var, you are printing that var. So computer basically follow the sequence that how you write in your programs. Now this is not always true that we always have the sequence structures. You can have some other different structures in your program. That is called control structures. Sometimes statement controls the sequence. Statement controls the flow of executions. Here you see, if you go back to the previous slide, here the flow of execution, how flow of execution happen one by one. So it's just following the sequence, how you write the program. But it could be possible that your program can change the flow of executions based on some conditions. You might have some conditions in your program. If condition satisfied, then you follow one path. If condition not satisfied, then you follow other path. So that means how your program execute, that depends on some conditions, based on some conditions. So a statement might have some conditions, expressions, Boolean expressions. And if Boolean expression is written true, then you follow one path. If Boolean expression written false, then you follow other path. Here in this example, you see that you have some condition over here, C1, and you have some if statement that if this condition is true, then you go this path and execute statement 1, statement 2, statement 3. Now, if C1 is not true, then don't go there, just jump to the next statement. The next statement is S4. The next statement is S4. So this one, take the pen. This one is the S4, next statement. So tell me again. So you have if statement, and this if statement has some conditions. If condition is true, you go this path and execute statement 1, statement 2, statement 3. Then after statement 3, you execute statement 4. Now, if condition is false, let's take another color pen. Where is my pen colors? Let's take blue colors. If condition is false, then you go to statement 4. So that means this block of statement will be executed if condition is true. This block of statement will be executed if condition is true. So now you can see that the flow of executions in your program depends on some condition. If condition true, you execute something. If condition not true, then you probably skip that statement. You probably go to other statements. Let's see one examples. Here, one examples. You check if var is less than 5 or not. If var is less than 5, then go to this block, and do this operation, var equal to var plus 1, x assigned by 2 plus 3, and var assigned by var divided x. So if var is less than 5, then it is true. If it is true, then you execute these all statement and finally print the var. Now, if var is not equal to 5, is not less than 5, sorry, if var is not less than 5, just imagine that var equal to 5 or var greater than 5, then it will not go this block, it will just go here and print the var. That's the things happen in our programs. We might need some conditions to, just, follow the execution of the programs. Now you play games, you probably play some video games, right? So in a video game is just like a program, right? It's just made by some different programmers or software developers. You probably do lots of things in your games, right? So they have several conditions. If something happened, you take another actions. If something not happened, you take another actions. If you attack by some huge powers, then probably you get a higher power. You get some higher power. If you don't need higher power, you just use some less powerful weapon, something like that. These are the conditions. So flow of executions depends on different conditions, and this kind of structure called control structures. So our program might have some control structures, and this is one of them. Now you see that these are the conditions. Let's see another paint colors, red colors. You see this condition 1 or this one we have seen over here in our examples. These are Boolean expressions. So what is Boolean expression? We already covered in our previous class, previous lectures. Boolean expression is something which returns only true or false using some comparison operator or relational operator. You see, this is the operators. These are called relational operator and comparison operators. So these Boolean expressions always return either true or false. It doesn't return anything. Let's go to the next slide. To see these Boolean expressions. This Boolean expression, what is Boolean expression? Boolean expression is an expression that evaluates a Boolean value true or false. It doesn't return any other true or false. It returns either true or false. And in order to do that, we use some relational operators. Greater than sign, equal to sign, less than sign, greater than equal to sign, less than equal to sign, not equal to sign. These are the operators we covered in our previous lectures. And those only returns, true or false. You see over here, true or false. This examples, a greater than 5, true if a is greater than b, otherwise it returns false, right? If a is greater than b, then it returns true, otherwise it returns false. And we use these comparison operators that we have covered in our previous lectures. So we have several comparison operators. Greater than sign is one of the comparison operators. So in these two slides, we understood we have control structures. We can have control structure in our programs, and this control structure has some conditions, and that conditions basically decide where we should go. We should go to right path, we should go to left path. That depends on our results from the Boolean expressions. And that Boolean expressions can return true or false. If it is true, we go one side. If it is false, we go other side. This is not a sequence structure. This is control structures. So let's see some examples, some implementation of the control structures. So we'll see different type of control structures in our programs. The one of the most widely used control structure is if statement. We already have seen our examples, if statement. The if statement basically gives you, if the condition is true, you go some path. If the condition is not true, you skip that path. This is just a one-way path. You don't have alternate options. You don't have alternate option. It's just saying that, it's something. Just take one examples. If it is a raining, you take an umbrella and go to school. If it is not raining, you go to school. You don't take umbrella, right? Just it's one-way path. There is no other option. It's not telling anything that if it is not raining, you take sunglasses. It's not telling something like that. It's saying that if it is raining, take an umbrella, go to school. If it is not raining, then go to school. So you take the umbrella if it is raining. And if it is not raining, you just skip that thing. You don't worry about the umbrella. You don't need to take any other things. So that is the one-way path. And you don't have any other alternate options. You are going to school, that's a normal statement. But whether you are taking that umbrella or not, that depends on raining. So you can have these sort of things, these sort of situations in your programs. So single alternative decision structures provide only one alternative path of executions. So you see in this example, if condition is true, you execute these statements, statement 1, statement 2, and statement 3. If condition is not true, then you execute statement 4. So statement 4 is obvious. Even after executing statement 3, you will execute the statement 4. But if the condition is false, you are just skipping this whole blocks. You jump to the statement 4 and execute that statement 4. So we see these examples in our previous slide also. If var is less than 5, then you go this block and you do all those statements. Var assigned by var plus 1, x assigned by 2 plus 3, then var assigned by var divided by x. Then print the var. If var is equal to 5 or greater than 5, then jump to the print var sections, print the var. That's it. Okay, so this is a one-way path, and that's called if statement. And we use some if keyword over here. You see the if is a keyword, it basically checks the condition. If condition is true, go to one path. If condition is false, go to other way. Now come to the flow charts. So flow charts basically, some design on your paper, how your program design. So usually when programmer or software developer write a program, they basically design flowchart first. Okay, so that's the design section. So it's just imagine you are going to build a house. Okay, if you're going to build a house, you probably not going to build the house without doing any design. So what you do, you will design first, then you check that your design is perfect. It will not create any problem when you're building the house. Then you jump to build a house. So similarly, a programmer or software developer, before jumping to coding, before jumping to code any program, it design the program first on paper and check that whether it's good or not. If it is good, then it goes for coding. And another good thing for designing is that, so say for instance, you know Java, I know Python, and other people know C++, but we don't know different language, right? So I don't know all the language, you don't know all the language. So if you write a program in Java language, probably I don't understand what you wrote. So that's why we need some language which can be understood by everybody. So design is something that is understood by everybody. So these flowcharts is kind of a design. So whether you are going for writing any program in Java or in Python or any other language, if you design will be the same, at the same way. So I can understand this design, you will understand that design. Other people who knows C or C++, he will understand this design. So design is an universal language for everybody, so anybody can understand, right? So that's called, flowcharts. So when we create programs, we basically create different flowcharts, design some flowcharts. So these flowcharts, you see that this diamond sign, this sign is for Boolean expressions. The sign is for Boolean expressions. If this Boolean expression is true, then we jump to this block and it does all these operations. If Boolean expression is false, it's jump to this statement. Now, if you see the flowcharts, so if Boolean expression is true, it goes to this block, it apply all those statements, then it goes to print var. You see the path, that path finally goes to the print var. But if you var less than 5 is false, then it's goes to the print var directly. It's just skipping this whole things. So diamond represent true or false conditions, Boolean expressions. Rectangle box is for representing statement. You see that these are the statement, that's why it's a rectangle box. And perform the actions when a condition is true. If condition is not true, exit the structures. So if condition is not true, it's just basically exit the control structure and go to the sequence structures. So this is the portion of the sequence structure. You might have some other statement also after that. So flowcharts of if statements, the design of the flowcharts, we see that if it is true, then go there. If it is false, go there. Now let's do one examples on our database. Okay, so this is our programs. We have a class, my computer class, and we have a main methods. Just remove everything. Let's remove everything. And we have something, say int value equal to 10. Okay, this is my variables value. We say that if value modulus 2 equal to 0, then this is our if statement. Inside the if statement we have some other statements. So we write system dot out dot println, and we write our value is divisible by 2. Then we finally suspend system dot out dot print line, right? Goodbye. Okay, so this is my small program. So just see, this is my first statement. This is my if statement, my control structures, and this is my third statement. If I write, say for instance, if I write something like that, this is my statement 1, and this is my statement 2, and this is my, say, statement 3. If you think it's a sequential statement, this is first statement, this is second statement, and this is third statement. Now in the second statement we check some condition. If condition is true, if it returns true, then it will execute this one. If it is not true, then it will go to the third statement. It will not do anything for these things. So you can have several statements over here, say SS1, SS2, SS3. So you have several statements over here inside these things. Just try to understand. So you have, statement 1, that assignment statement, you have value 10 in these variables, and you have the second statement, that is a if conditions. If condition is true, then it will perform these statements. If condition is false, then it will not do anything. It will go to the statement 3. Just imagine if the condition is true, it will do everything over here, then it will perform these things. So statement 3 is obvious. Statement 3 always comes statement 2. Either statement 2 is true or false, it doesn't matter. Statement 3 will be executed. If statement 2 is true, then it will execute this one. If statement 2 is not true, then it will not execute this one. Then after that, it will perform the statement 3. Now, the conditions, what we are trying to say over here, if value modulus 2 equal to 0, that means if there is no any remainders, if the remainder is 0, that means value is divisible by 2. Value is divisible by 2. If value is not divisible by 2, that means it might have some remainders. Say for instance, you have 11. So if 11 is not divisible by 2, because it will have remainder 1. So that time it will be false. Okay, let's try. Let's have the 10 over here and on the program. Okay, so you see that it is saying that our value is divisible by 2 because we have 10 and value modulus 2. That means it is divisible by 2. There is no any remainders. So we see that value modulus 2 return 0 and 0 equal to 0 return true. So that's why it's printing our value is divisible by 2, then it's printing goodbye. You see that our visible is 2, then goodbye. Now imagine we have the 13. Okay, we have 13. So 13 is not divisible by 2 because it will have remainder 1. That time, if you run the program and you see that it's not printing this line, it's just printing goodbye. That means this condition is not true over here. Since this condition is not true, so it's not printing anything over here. It's not executing anything over here. It's just printing goodbye. So if condition is just a one path, if condition is true, it executes something. If condition is not true, it doesn't execute that things. It go for the next statement. Now you can have some other choice. Say for instance, you can say your program, if this condition is true, you perform this one, otherwise you perform that one. But now you have the two paths, right? Just imagine I'm telling you in real life examples. Okay, if it is raining, take umbrella, go to school. Otherwise, take sunglass, go to school. You see this, there's two paths. If it is raining, take umbrella, go to school. Otherwise, take sunglass, go to school. So taking sunglass and taking umbrella depends on the raining. If it is not raining, take sunglass. If it is raining, take umbrella. Now you have the two paths. Before we have said that if it is raining, take umbrella, go to school. Otherwise, go to school. I didn't say take sunglass that time. That was only one path. Now I'm saying that if it is raining, take umbrella, go to school. If it is not raining, take sunglass, go to school. Now you have the two options, right? That called two-way path. Two-way if-else statement. Decide which statement to execute based on whether the condition true or false. If it is true, execute something. If it is false, execute something else. Dual alternative decision structures to possible path of executions. One is takes if the condition is true and other of the condition is false. Now you see these examples. You see the if, you see the if, then we have the conditions. If condition is true, execute statement 1. If condition is false, execute statement 2. Then finally execute statement 3. Just imagine if your condition is true. Then what would happen? You execute statement 1, then you execute statement 3. Now imagine that your condition is false. So what will happen? You execute statement 2, then statement 3. So statement 1 or statement 2, which one would be executed, that would be based on conditions. If condition is true, then you will execute a statement 1. If condition is false, you will execute statement 2. And finally, you will execute the statement 3. So it doesn't matter whether it is true or false. Statement 3 always be executed because that is out of the control structures. That is out of the if statement. That is not a if statement part. That is just some other statements. Now you see the same examples, what we have seen in our previous one, something a little bit modified versions. A var less than 5, then var assigned by var plus 1. So if the condition is true, if var is less than 5, then var will be assigned by var plus 1. If var is equal 5 or var is greater than 5, then var will be assigned by var by 2. So these portions will be executed if it is true. And these portion will be executed if it is false. If it is false. And finally, you print the var. So these are the things called, if-else statement. So previous one was if statement. Now it is if-else statement. So you have if it is something, then you do something, else do other things. So now let's see the flow charts that we have seen. The flow chart for the if statement. Now we are seeing the flow chart for the if-else statement. So we know that this one is our Boolean expressions. A var less than 5, if it is true, then go there and execute this statement, var assigned by var plus 1, then print the var. Now, take the another scenario, another case. If var is equal 5 or var is greater than 5, then it is false. Go there, var will be assigned by var by 2 and print the var. So these are the two different paths, right? Two different paths. So you check the conditions, and based on the conditions, you perform one of the statement, true or false. Then finally you print the var. That's the if-else statement flowcharts, and we understand what is flowcharts. Now let's see one example of if-else conditions. Okay, so that was my, let's see, let's take, different, portions. Okay, let's write everything from beginning. So we have a class, we have a main functions. So in the main functions, we have some variables called value, and we have some 12. Okay, now we have some conditions. If value modulus 2 equal to 0, you print line, and you see our value is even. You know what is even? Even number is divisible by 2, and odd number is not divisible by 2. 1, 3. So what is the, let's give example or our even some examples. Say even numbers. Even numbers. Say what are the even numbers? 2, 4, 6, 8, 10, 12, 14, 16. These are even numbers because these all are divisible by 2. So what are the odd numbers? Odd numbers. So what are the odd numbers? 1, 3, 5, 5, 7, 9, 11, 13. These are the odd numbers, and these numbers are not divisible by 2. So even number and odd numbers. So now we can check whether my given number is odd or even. So you can say if value modulus 2 equal to 0, it means if there is no any remainders, that means value is divisible by 2, then we can say our value is even. Now, second, else, that we didn't have in our previous examples. So we write system dot out dot print line. We write our value is odd. And finally, we are done with the control statement. Then we finally write system dot out dot println goodbye. Okay. So which one is the statement one? Remember, this is my statement one. Okay, this is my statement one, and this is my statement two, which is my if statement, if else statement, and this whole thing is one statement that's called if else statement. So if it is true, then run this one. If it is false, then run this one. So this is the if part, and this is the else part. If it is true, then run this one, otherwise run this one. The whole thing is statement 2. Now, finally, we have the statement 3. Statement 3. So if the condition is true, you run this one and then run this one. Goodbye. If condition is false, you run this one, then you print the goodbye. So let's run the program and see what happened. If value is 12, that is divisible by 2. So that is even numbers. So it should print even numbers. Let's see. You say that our value is even. Goodbye. Now let's try 13. And we know that 13 is not divisible by 2. So we can have message our value is odd, and then goodbye. So run the programs. So our value is odd, and goodbye. So the message which is executed, that basically depends on the conditions. This is the else portions, this is the if portions. Let's go back to the slide again. So we understand how to write a if conditions. Then we understood how to write if else statements. If is a one-way path, and if else is a two-way path. So if something is wrong, something is true, run this one. Something is false, then run other ones. Now you can have some control structures, nested control structures. So you can have if condition inside another if conditions. This is possible, right? This is possible. So we'll see some examples and some code over here. So nested controls are decision structures. That means some if statement, some if conditions inside another if conditions. You can have something like that possible. So if you see these examples, determine if someone qualifies for a loan. The must meet two conditions. Must earn at least 30,000 per year. That is first conditions. If someone earn 30,000 per year and must have been employed for at least 2 years. If he is employed at least for 2 years and if he earns at least 30,000 per year, then he will be qualified. He or she will be qualified for loan. Now you understand, if first condition is true, then you go for the next if conditions. If the next if condition is true, then you qualify for loan. If the first condition is false, then you are not going to check the second condition, because he will be not, qualified. If first condition is true, but second condition is false, even he will not be qualified for the loan. So this problem is just like a, if condition inside another if condition. If you see our flowcharts, you see this one. If salary is greater than 30,000, greater than equal to 30,000, if it is true, you go there and you check that if job year greater than equal to 2, if it is true, then you are qualified. If job year not satisfied, then you are disqualified. Similarly, if salary is not greater than equal to 30,000, you are disqualified. So this is one if conditions. It has true and false path, and you follow the true false path. You check the next condition. It also has true and false path. You follow the true path for the qualified. If it is false, you are disqualified. And for the first condition also, if it is false, then you are disqualified. So this is the way how you can write if conditions inside another if conditions. Let's go to the NetBeans and write the same problem in our programs. Okay. So let's have the similar programs. So if you have the flow chart in that way, so it's easy to convert them into, programs. So that's why people design before writing any program. That's a good way to be a programmers. Okay, so let's have two variables. The first variable is salary, and let's have salary is 31,000. Okay, like int. Then we have int job year, that is, say, for instance, 3. Okay, now you have write your if conditions. First if conditions, outer if conditions. If salary, if salary greater than equal to 30,000, you go for the next if conditions. Okay, so you write your inner if conditions later. If it is true, do something. If it is false, print, you are disqualified. Okay. System.out.println, you write your salary is not smart enough, so you are disqualified. So this is your else portions. If salary is greater than 30,000, you do something. Otherwise, you write, if it is not satisfied, you write your salary is not smart enough, so you are disqualified. Now you have to write the second if condition inside that. So how to write? You write if, you now check the conditions, second condition, if job year not greater than equal to 2, then you write something, and if it is not satisfied, you write your else portions. So if job year not greater than equal to 2, then you do something. So you write system dot out dot print line, you write you are qualified for the loan. Okay, because he satisfied these conditions, then go inside, then he satisfied this condition, go inside, then you print you are qualified for the loan. Now, if this condition is not satisfied, then you write system dot out dot print line, you write your job year is not sufficient. So you are disqualified. So you see. Okay. So what is the issue over here? Expected this one. Okay. Now let's see the whole program. Okay. So you have two variables. One is salary. One is the job year. So if job year greater than equal to 2, sorry, if salary is 30,000 or greater than 30,000, you go inside, then you check that if job year greater than equal to 2, then you go inside and print you are qualified for the loan. And if the first expression is false, you are not going inside, that means you are skipping everything, and you come here, you write your salary is not smart enough, so you are disqualified. You can think another case, your salary is greater than equal to 30,000, that is true. You go inside, then you check the job year equal to 2, greater than equal to 2. If it is false, then you skip these portions, you print this one, your job year is not satisfied, so you are disqualified. Then come back, and finally you have some statements. Say for example, your third statement, you write system dot out dot. This is not a part of the control structure. This is not a part of the equal structure. It's just a goodbye in our previous example. Thank you. So this is what statement one. Statement one. Then you have the statement 2. Then you have the statement 3. The whole thing is statement 3. This whole thing is statement 3. And finally, you have the statement 4. Okay, so inside the statement 3, you have some more conditions. Now run the program and see what happens. So it's printing, where's my program? It's printing, you are qualified for the loan. Thank you. Because it has 31,000 salary and job year 3. Now let's have job year 1. So run the programs and you see your job year is not sufficient, so you are disqualified. Thank you. So this condition is not true, not satisfied. So that's why he is disqualified. Let's say you have 4 years and you have $20,000. Now if you run the programs and you see that it's printing, your salary is not smart enough, so you are disqualified. Okay, so these are the things. You can have multiple conditions, inside, one if, another if. And this thing is called nested, control structures or nested decision structures. Okay, so now these things, this program can be written in a different way also. Just imagine we have covered in our previous example that, logical operators, AND operators and OR operator. So these programs can be simplified using AND operator and OR operators without having lots of if conditions. So let's try in a that way. So remove everything over here. Just imagine that you have three statements, statement 1, statement 2, and statement 4, and you don't have control structure yet. Now you can write your control structures. You don't like to have so complex program having nested if conditions. So you can have something like that, say, if salary greater than equal to 30,000 and job year greater than equal to 2, then you print system dot out dot print line. You write you are qualified for the loan. Else system dot out dot print line, you are disqualified. So you see that you just checking if salary greater than 30,000 and job year greater than equal to 2, then you are qualified for the loan. Otherwise, you are disqualified. So you have only one if condition and you can write the same program. The problem is that you cannot have separate message. So why you are disqualified? So you are disqualified, but what is the reason? The reason is salary or job year. So you cannot, write that, specifically using the one if condition. But at least you can say that, you are qualified or not. So if you want to mention you are qualified, you are disqualified for salary, or you are disqualified job year, then probably you need to write another if conditions. So using the single if conditions, you can write the program, same program, but you cannot have specific, message. So which one is the reason for your disqualifications? Now let's run the programs and you'll see that it's giving nice results. So go there. It's that you are disqualified. Why it is disqualified? Because you have the salary 20,000, right? So this is the reason, but we don't know what is the reasons over here by seeing the message. So you are disqualified. We know that we are disqualified, but we don't know what is the reason. Now, if you have the 30,000 over here, so you write 30,000 over here and write the programs, and you see that you are qualified for the loan because you have the salary 30,000 and you have the job year, that is 4 years. So you are fine, you are qualified for the loan. So a problem can be solved in a different way. You can solve using the multiple if conditions, nested if conditions. You can write a single if condition with the logical operators that we have covered in our previous lectures. But you see what is the limitations in both cases. The previous one has a lot of code, little bit complex. The second one is simple, doesn't have a lot of code, but the second one is not more specific. It doesn't have specific masses for different purpose, but the previous one had. So you'll decide what to do, what is the best solutions for you. Okay, go back to the our slides. So far we have things different if conditions using if one-way if conditions, then we have seen two-way if conditions, then we have seen nested loop decision structures, and we have seen different examples. Now we have else if statement, which is different variations of our nested loop versions. So if you think that nested loop is little bit complex, we don't like, it makes our program ugly, then probably we can choose the else if statement. So else if statement is the different variations of the not nested loop, sorry, nested if conditions. So we can try that one. Say for examples, there is an examples. If condition C1 is true, then run the statement 1. Else, if condition C2 is true, then run the statement 2. Otherwise, statement 3. You see the differences. There are 3 ways. So you can have multiple ways. So far we have seen the 2 ways. If it is raining, you take umbrella, go to school. If it is not raining, you take sunglasses and go to school. Now you can say the statement in a different way also. So that was the previous example, only 2. You have to follow one of the way. If it is raining, you take umbrella, go to school. If it is not raining, you take sunglasses, go to school. That means you are taking something. You are taking one of them before going to school. But you can say in that way also. If it is raining, you take umbrella, go to school. If it is shining, take sunglasses, go to school. Otherwise, go to school. Possible, right? So taking sunglasses also depends on some conditions. Let me tell you again. If it is raining, take an umbrella and go to school. If it is shining, take sunglasses, go to school. Otherwise, go to school. So there is a chance that you are not taking anything. So this way you can have a lot of conditions. And using the conditions, you can perform different operations. Raining, I'm taking umbrella. Shining, taking sunglasses. Otherwise, nothing. You don't have raining, you don't have shining, just normal, not shining, some gloomy day, but not raining. Then you don't take anything. So you can have multiple conditions. Based on the multiple condition, you perform different things. So in this example, you see if var less than 5, then perform var equal to assigned by var plus 1. Else if var greater than 5, your var will be assigned by var by 2. Otherwise, print var. That means, so when var less than 5, you are doing something, some statement, but you are not printing. If var greater than 5, you are doing some operations and assigning to var, but you are not printing. But when var equal to 5, if var is not less than 5, if var is not greater than 5, so what would be the var? Var should be equal to 5. If var is equal to 5, then you print the var. So what we are saying, if this condition is true, you perform this one. If this condition is true, you perform this one. Otherwise, you perform this one. Okay. So let's see one code examples using the if-else conditions. Go to the NetBeans. Let's modify these things. Okay, let's modify these things. you can write these things. You have seen the different versions of these programs. Let's see another versions using the else if conditions. You write if salary, less than 30,000, you write system dot out dot print line, sorry, your salary is not smart enough, so you are disqualified. So if salary is less than 30,000, you are doing in a different way. You are checking it is salary is less than 30,000 or not. So imagine that your salary is equal to 30,000 or greater than 30,000. Now you check this second, conditions. If job year less than 2, so you write system dot out dot print line, right? You don't have at least 2 years job experience or job lifetime, something like that. Okay. So the first condition check that if salary is less than 30,000, you are disqualified. Second condition check that if job year is less than 2, your job lifetime, so you are disqualified. Okay. Now finally, if this is true, it will print that one. If this is not true, then it will check this one. If this is true, then it will print this one. If this is not true, then finally it will print this one. So it will print, the final things will print if both of them are false. We'll talk about this one. Okay. System dot print line. You are qualified for the loan. Okay, so finally we have the statement 3. This is our statement 3. Okay, no, statement 4, sorry, statement 4, and this is our statement 3, our control loop, control structures. The whole thing was structure. So you see that we didn't write any nested if conditions. We use else if conditions, and we are having the different message. Now we can see if someone is disqualified, we can understand what is the reason for disqualifications. If somebody is qualified, that means it satisfied the both conditions. So when we have if, else, if conditions, computer first check this one. If it is true, then it will not check any of the following if, else, or else conditions. It will jump to the following statements. Remember one more times. If this condition is true, it will print this one, then jump to the next statements. It will not check any of those things because it's already satisfied these conditions. It doesn't need to check any of them. Now imagine that this condition is not true, this condition is false. Now computer will check the second conditions. If this condition is true, then it will print this one and skip all other conditions, all other branches, and jump to the next statements. So if second condition is true, it will print this one and jump to the thank you. Now, if it's written, if it's execute this one, that means this one is false, this one is false. Now it's printing this one. So since both are false, that's why it's printing this one. And finally, it is printing this one. So computer, what I'm trying to say, so it checks conditions one by one. If any of the condition is true, then it's not checking any other conditions, following conditions. It jump to the next statements. Okay, so let's run the program and see. So you are qualified for the loan, thank you. So why he is qualified? Because his salary is 30,000 and job year is 4. Now, let's say his salary is, just imagine, his salary is 20,000. Now run the programs. It's printing. What is printing? It's printing. Sorry, your salary is not smart enough, so you are disqualified because he has 20,000 salary. So that's why he's qualified. The reason for disqualification is his salary is not smart enough. Now let's say he has 40,000 salary and he has only 1 job years. Then run the programs. And he's saying that you don't have at least 2-year job lifetime, so you are disqualified. So this is another reason for disqualifications. He doesn't have 2 years job lifetime, so that's why he was not qualified for the loan. So this is another way how you can solve the same problem that we have seen without having some nested loop. So nested loop sometimes looks ugly. It makes our program so complex, but depends. Sometimes we need to write our nested if conditions in our program. That might be mandatory, that might be only way to solve the problem. So that depends on the problems. So this one is if else if things. So this all about some control structures. That's the if conditions, if else conditions, else if conditions, and nested loop. So we'll do one more examples using if else if to make you more clear how to how to solve any problem using if else if conditions or control structures. Let's move to some NetBeans. Just imagine that you want to solve the problems of our grading systems. So for instance, you are writing a programs and you want to print something, you want to print a grade based on the mark. If someone get more than 90, then he will get a grade. If someone get more than 80 and less than 90, he will get B grade. If someone get 70 and less than 80, he will get C grade. And someone get 60 to 70, then he will get D grade, and otherwise he will fail. So this problem can be solved using if else if problem, right? So let's think how to solve the problem. So let's write the problem first, then we can write the programs. So what we are trying to do, so for instance, so let's write. So 92, 100 is for A grade, then 82, 89, B grade, 72, 79, C grade, then 62, 50, sorry, 69 is D grade, and otherwise F grade, fail. Okay, so you have to write your programs to solve the problems. So let's have a variables. That variables takes marks. So you can say int score. Okay, some score, say for instance, just write 89. Okay, then you have char that contains the grade. So you don't need any variables for char. You just want to print the grade. Okay, so this is your only one variable that you need for the programs. Now write the programs. Just simple if score greater than equal to 90 and less than equal to 100, then sorry, this is not end signed. End. Okay, score. Okay, so now you write system dot out dot print line. You write your grade is A. So now you have the else if again. So you write, follow the same things. So you have else if score greater than equal to 80 and score less than equal to 90, then not equal to because less than 90. Then you have system.out println grade B. So your grade is B. Now you have another else if, and you have score greater than equal to 70 and score less than 80. So you write your grade is C. So then else if you write score greater than, or you can write greater than equal to 60 and score less than 70, you write you got D. And finally you say else you are fail, you got F, something like that. So your grade is F. Okay, so you see that this is the F, if else if conditions. Now finally you can have some thank you message. Okay, now run the programs. Run the programs, and it's saying that your grade is B. So why your grade is B printing? Because your score is 89. And we know that 89 falls over here. Greater than equal to 80 and less than equal to 90. So this condition is true. This is not true. It's not in between 90 and 100. So since it is not in between this one, so that's why it is checking this one and it's satisfied and it's printing this one. Now let's you have 99 or you have say 90 94. Okay, now it should print A. You see that your grade is A because it falls in these conditions and it satisfies these conditions. Now imagine that he has 40. Okay, 40. Now the programs and your grade is F because 40 doesn't satisfy these things, doesn't satisfy this thing, doesn't satisfy these things, doesn't satisfy these things, and finally it has else portions, and the else portion has the if. So that's why it's printing F. And finally it's print thank you. Now do you see that it has one logical problem? So I don't know whether you can understood or not. There is a logical problem. Let's see what is the problem. Imagine that someone entered score 140. Okay, it's more than 100, more than 100. So someone got 140. It's not possible in practically, but but when you write a programs, you have to think some situations. You have to think about some situation which is abnormal. Is a user can put a lot of things. You don't know what they will put, what they will enter. So someone enters the 140 mistakenly. So how your program will behave? So if you run the programs and you see that your grade is F. So don't you think that this message is not correct for this score? So 140 might be a wrong numbers, but you cannot say that you are failed. So you can give different message. Someone put mistakenly 140, but you cannot say your grade is F because 140 is not F. We understood 140 might be a wrong numbers, but at least you cannot say that it is F. You can give different answers. That's why these sort of things you have to think some abnormal situations. So how your program will behave if something abnormal situation happen. Here is the abnormal situations. Now in that case, you can tell. So you can tell you might have some another else if score greater than equal to 0 and score less than 60, your grade is F. And finally you say else. So you can write invalid score. Invalid score. Okay. If given score is not in your range, then probably it would be invalid score. That user can understand. So he or she did some mistakes. So run the program and you see that it's writing invalid score because 140 might not be a valid score. You can try some other numbers. Say, for instance, you can try -9, -9. That should be invalid numbers, right? That should be invalid numbers. You see that? Invalid score. Now you try 30. So you print that one, and you see that your grade is F. So these are the things we have tried different if and if else conditions, else if conditions for different programs, and we have seen that how logical mistakes can be happen. So when you write a program, you have to think in that way. So in the next lectures, we'll talk about some other type of control structures, how we can use those control structure for different purpose. We'll talk about those things. And this is all about for these lectures. Thank you.